Good day. I would like to talk to you a bit about the smart grid and the cloud and how OPC UA fits into this picture and how OPC UA is a platform that will help make the smart grid reality. The vision for smart grid is this massive network of applications and devices interconnected via a common network infrastructure, who's collectively called the cloud. This network infrastructure can include different physical network layers. It could include an enterprise service bus, which supports the exchange of asynchronous messaging, and obviously all of these different applications need to have some sort of common language to talk to each other. The first part of that common language is a common semantic model, where all of the basic entities which are of interest to these kinds of applications are standardized, and as part of the smart grid effort, the common information model, or SIM, is being used as a basis to develop these objects, which are then going to be used by the different applications that connect to the smart grid. Now, UA itself doesn't is it provides a very flexible information model that can take these standard semantics and represent them naturally within the UA server address space without any loss of information or data. Now, when you get down to the bits and bytes, applications have to have a common protocol, and and one of the beauties of the service-oriented architecture, which UA is based on, is it's possible to take a UA server and extend it to support different interfaces depending on the needs. And in the smart grid context, there's a lot of efforts being spent developing XML messages that contain standard information based on the SIM model. And so the demonstration I'll be doing a bit later, and sort of the general concept for UA servers within the address space, would include a endpoint that's able to receive this information, receive XML messages. And the UA server would then integrate this information into its address space, combine it with other information it's getting from other places. In this case, the UA application is a front end for a number of meters, which could be using any number of different protocols, and all of this information is integrated and then presented to a UA client as a coherent model that hides the details of where this information actually came from. Now, and this is sort of to go a bit more in terms of how UA fits in. One of the powerful concept behind the smart grid is effectively would be creating this massive peer-to-peer distributed database of SIM objects that can then be accessed from different points within the system, and modified, and have those changes sort of reflected across the system. However, actually doing this interaction, as soon as you have a human try and get into the network and try to understand what's going on, try to and react to the information the network is giving it, or potentially change what the network is doing, there needs to be some sort of user interface developed. And OPC, which has been in the industrial automation interface, industrial automation market for over 15 years now, has created a suite of protocols that support development of standard applications, standard client visualization tools, standard historians, and other sorts of standard applications that make it easy for different users with different interests to sort of go into the data that's being exposed, organize the data according to the way they need it, and allow them to make the decisions and perform the actions that they need to do based on whatever task they need to solve. So I'll be getting into an actual demonstration in a bit, and some of the key concepts that I will be showing you. The first is the UA information model, extensible full mesh model that allows users to visually explore the SIM objects in their canonical form. This information will be coming in off the network via the XML-based messaging mechanisms, and it will be ingest and incorporated into the server address space and made available to clients. In addition, the server can organize these objects based on whatever the user needs are, and I'll show you how that can be done in different ways. UA also supports the exchange of type information, so it's not limited to simply the standard SIM objects. You can extend this to provide virtually any kind of information that might be useful. That schema can then be communicated to clients that can then can be developed to use that information. It's very important, it's very handy when it comes to extending your applications beyond the scope of what they originally intended. One of the more powerful features of UA will be the topic selection, or otherwise known as event filtering. There's a huge number of events and a huge amount of information that's going to be passing across the network, but the UA server provides a very simple mechanism to allow users to select only the information that they're interested in, and make it easier for them to react to events that are of interest to them. The next interesting thing that I'll be showing you is the concept of UA smart objects. SIM objects are data, and they don't really do much in themselves. They're just a way of describing an entity. Well, UA can then allows you to take this data and add behavior to it, allows you to add methods to allow clients to interact with the objects that are represented by these entities, and do so in a standard way without actually having to know anything about what the real underlying system is. And the most interesting thing about the demos, I'm going to be using some off-the-shelf applications that have no advanced knowledge of the smart grid or the SIM or any of the information model concepts that I'm discussing, but you still will be able to use them to develop interesting applications. So the server is already running, and I'm starting up this generic UA client application. This particular client application is intended to be a test tool, so it doesn't provide the same level of visualization capabilities that there's some more sophisticated clients that are available, and but it does allow us to illustrate and walk through the things in UA. And now the first thing that you see here is that once I've connected, is I now can see the address space in the UA server. And the first thing I want to show is the SIM class hierarchy. And underneath the SIM classes, for each different SIM class type, you see all of the instances which are known to the server. Now, what's interesting is the UA server has actually no knowledge of any of these SIM objects. These SIM objects are constructed because of dynamically as messages are coming in via the XML messaging interface. And these are constructed independently and then all merged together. So a message describing the set of meters that are currently available will come in, and that meter will have a reference to an identifier for the service location. Well, at a later time, a message coming in with the information about the service location will show up at the server, and then that will get and then the UA server is able to take that message, ingest it, and then create and fill in all the different properties from the XML, and then ensure that they're linked together. Everything is linked together in a transparent address space, which a client can freely walk through and look at the different pieces of information and help make decisions on what they want to do with this information. So in addition to the basic organization by SIM class, it's also possible to create different hierarchies. So we have the different meter group. We have two examples here. One is a hierarchy organizing the meters by geography to the east and west, and then we have another hierarchy, which is a logical grouping, where we've created some arbitrary groups called Group 1 and Group 2, and these could be groups that count. These could be organizations that come from the SIM model. They could be organizations that are defined by the server based on its configuration, or they could be organizations that were manually created by clients based on how they need to look at the information. Now, once you've created these different hierarchies, it's now possible to then use these hierarchies for your basis for your filters. So if I want to get information, any event from meters in group 2, all I need to do is drag group 2 into this event subscription, and we'll now see that every time something happens to either meter, in this case meter B or meter C, I get an event. And right now we're only seeing events for meter B, because that's the only one that actually has anything going on right now. Now, as I said, the actual object itself is constructed based on the XML data that's coming into the server. However, in the case of meters, this server extends the meters and adds some specialized functionality that advanced features using the basic UA mechanisms. So in this case, the meter has what we call in UA as a method. This is an arbitrary function that can be called, and this is called schedule read. So what I can do is I'm using this generic feature to call this method, and I get a list of arguments that I can type in. Now, it's important to remember this is a generic client application. It knows nothing about the SIM, and this dialog is being generated by reading the address space, and it now allows a client to fill this in and then invoke the method, and I've now started a schedule read for meter C. And as you can see that now, because I've now got this periodic read going on, the meter C is now generating events every so often, and that filter for group 2 that I had set up earlier is now receiving events for meter C. So in addition to just allowing the when a client starts a scheduled read, there is this concept of this process going on. The UA server creates this object that represents this ongoing activity, and it's also possible to stop this by calling another method. The Also, another consequence of the schedule read is that now you're getting the server's now getting regular updates for a particular quantity. In this case, the default quantity was net energy. So it's now possible to simply subscribe to that value like you would in any other process control system and get the current value for that 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 quantity. And the advantage of the one advantage of the UA server and this and the way this demo is that these meters themselves may be relatively cheap devices and they can't support a large number of clients. So the UA server becomes a gateway that can optimize connections to the underlying server. So it's smart enough to know that is to take all the requests from all the different compliance and combine them together and make sure that there's only one request going out to the actual meter, and then every client that is interested in that data will get an update whenever the server receives new data. The UA server could also implement history, could also be an archiver, which would allow, again, using a standard UA client application to set up trend views. In this case, this particular example doesn't actually support history, but it would be very easy to extend a server to archive the information as it's coming in, which would then allow much more sophisticated analysis applications to come in and use this historical information to make decisions about scheduling, about billing, about virtually anything else that is potentially useful in terms of optimizing the grid operation. So I hope you can see the potential of UA, and although I've given one example of how a UA server might look within the smart grid and the it is just one example. There's many ways to sort of to manage it, but the foundation that OPC UA offers in terms of a standard set of interfaces, standard filtering functionality, easy extensibility, a library of off-the-shelf clients that simplifies the process of developing your analysis applications. It is an option that definitely should be explored for many applications. Thank you.